video we will learn about close packing. Close packing are of three types. The first is 1D. In 1D, the atoms are arranged in a linear form, or we can say as in the same axis. If we talk about the relation between A and R, then this is R and R. We can see in this also. This is R and this is R. Okay, and this length is A. So it is A is equals to 2R. Then we talk about the coordination number. Coordination number means the ball is surrounded by how many other balls. So if we see of this ball, then it is surrounded by 1 and 2. So the coordination number is 2. Then we talk about the packing fraction. So packing fraction means area occupied by the cross section of atoms upon the area of square. So it is half pi r square, which is pi r square upon a square, and the value of a is 2r, and square of this, which is pi r square and 4r square cancel, and this is pi by 4. Then the second is 2 dimension. In 2 dimension, there are also two parts. To study this type of unit cell, we need the unit cell known as square planar. And to study this type of unit cell, we need unit cell known as hexagonal planar. In square planars, these balls are arranged in this axis and in this axis, and this is the square formed, and this length is A. So again the relation is A is equals to 2R, and these balls have 1 by 4 part in the square. So the packing fraction is again pi r square upon a square, and the value of this is 2r square, and this is pi by 4. And if we talk about the coordination number means that the ball is surrounded by how many other balls. So if we see this ball, then it is surrounded by 4 balls. So the coordination number is 4. And in hexagonal planar, the first row is arranged in this way, and the second is slightly shifted towards the pit or the empty space present between these two balls, and all the angles are 120-20, and these balls have 1 by 3 part in the hexagon, and this length is A, and these balls are R, so it is again A is equals to 2R. And if we talk about the packing fraction, then it is packing fraction is, this is pi r square, and this is again pi r square, which is 3 pi r square upon the area of the hexagon. So to find the area of hexagon, you all know that the hexagon has 6 equilateral triangles, and the angle of equilateral triangle is 60, 60, 60, and if I take this length as A, then all are A, and the area is half into base into height, so half into A into height. This is the height, so it is A sin 60, and the value of A sin 60 is root 3 by 2, and when we will solve, this is 3a square by 4, and total triangles are 6, so it is 6 into root 3a square by 4. Okay, then we put the value of A, 3 pi r square upon 6 into root 3, and A square means a value of A is 2r, so square of this is 4r square, and this 4 will go and multiply over here. 4 cancel, r square 1 2, so this is pi by 2 root 3. And if we talk about the coordination number, then one ball is surrounded by total 6 balls. So the coordination number is 6 in hexagonal planar. Then we talk about the third, which is 3 dimension. In 3 dimension there are also two parts. One is square planar and the second is hexagonal planar. In square planar there are two types. One is simple cubic and BCC. In simple cubic, these balls are in x-axis, y-axis and in z-axis. Then the cube is formed and this is known as simple cubic. And in BCC, the first layer is arranged like this and the second layer is arranged between the space between these two balls. So the BCC is formed. And in hexagonal planar there are also two types. One is HCP, means hexagonal close packing, and the second is FCC, or we can say as CCP. So in hexagonal close packing, we already discussed that the first row is arranged like this and the second is slightly shifted and the hexagon is formed. So space between them is of 6 balls, but only 3 balls can be fit if we give the numbering. And 1, 2, 3, 4, 5, 6. Only 3 balls can be, means 3 space can be filled. So of 1, 3 and 5. And in FCC, it can be filled of 1, 3, 5, and on the other layer it will be 2, 4, 6. You can see that in HCP, this first layer and this third layer are same. So and this middle layer, or we can say second layer, is different. So we can say it as it is a AB type. And in FCC, these 3 layers are different. So we can say as ABC type. Then we talk about the hexagonal close packing. In hexagonal close packing, these all are the lattice points of the hexagonal close packing, and in between this is the second layer, and again the same layer is repeated. If we talk about the effective number of atoms in that, then the 3 are of the middle, and these balls are 1/6 part. Okay, 1/6 part, and total are 12, 6 at the upper side and 6 at the lower side. 12 plus this ball has half part at the upper side and half at the lower side. So half into 2, which is 6. So the effective number of atom is 6. Then we talk about the packing fraction. So packing fraction is the element are 6, means effective number of atoms are 6 into, this is 4/3 pi r cube upon, we already discussed that in hexagons. This is the hexagon and the 6 triangles are formed and the angles are 60, and the area is half into base into height, which is √3/2, and the value is 3a square by 4, and total triangles are 6, so 6 into √3a square by 4, and into height. And to find height, you all know that this is the centroid and the center of the ball. This distance is h/2, and the distance between the centroid and the vertices is a/√3, a/√3, and this again a right triangle is formed, and these balls are touching to each other. So the relation is a is equals to 2r. Okay, and to find height, this will be h/2 square plus a/√3 square is equals to a square. So this will be h/2 square is equals to a square minus a/√3, means the √3 into √3 is 3, so it will be a square by 3, and this will be h/2 is equals to a and √2/3, and the value of a is 2r, so 2r and √2/3, and when this will be multiplied, 4r √2/3. Okay, so place of height we will put the value which is 4r, and root 3, the value was 4r root 2 by 3. Okay, and if we solve this, this will be 6 into 4 by 3 pi r cube upon, okay, this will be 6 into root 3, and the value of a is 2r, and the square will be 4r square, so it is 4r square, and this 4 will be multiplied into 4r, this is root 2 by 3, so this 4 is cancelled, r cube by r square, and this r, and this root 3, and this 6 is 6 cancelled, and so this 4 is also cancelled by this 4, so it is, the value is pi by 3 root 2, and the value of pi by 3 root 2 is 0.74, so the packing fraction will be 74%. So the packing fraction percentage is 74%. Thank you.